Speaker is Wei Zijun. I think Peter asked me to introduce the follow two speaker in Mandarin. 魏医师是北荣的泌尿科主任，然后他在这个UTUC 的这个泌尿道的这些癌症上面非常有研究，那他也参与了这个旗舰计划的一些合作，所以我想今天很高兴有机会在这次分享他的一些成果。Let's welcome Dr. Wei.
我还不是主任，谢谢采取。Good afternoon, ladies and gentlemen. I am Zhu Jingwei from Taipei Veterans General Hospital. Today I'm very honored here to present our study on the trans-ethnic comparative genomic study on UTUC, which is the abbreviation of upper tract urothelial carcinoma. This study was a collaboration among National Health Research Institute, National Yangming University, Kaohsiung Changgen Memorial Hospital, and Hirosaki University Hospital, Japan, and also Taipei Veterans General Hospital. So what is UTUC? If we divide the urinary collecting system, this is where the urothelial carcinoma originated. And from the upper side is the renal pelvis in the kidney, and then the ureter, and then the bladder. So the UTUC includes the upper two. So why do we focus on this UTUC? Because in Taiwan, the UTUC incidence is very high, higher than the Western country and Japan. As we can see here, in Japan and Western countries, the bladder represents the most common location of the UC. However, in Taiwan, the upper tract represents almost 1/3. And as to the male-female ratio, we can see that in Western country and Japan, the male predominant phenomenon is very obvious. However, this is reversed in Taiwan. And in Taiwan, the UTUC has higher prevalence, has rapidly progressing incidence. And in the UTUC, they are correlated with more non-smoker, female gender, and with the patients with chronic kidney disease. So from these three hospitals, we collect about 80 UTUC samples, and we did the core exome SNP array together with NGS with whole genome or whole exome sequence. Here is the clinical demographic data. As we can see that in Japan, still the male is predominant. And age of UTUC, the age of onset was about 70 years old. And in Japan, the smoking population was more prevalent. And the state distribution between Taiwan and Japan was a little bit different. But the stage, as we can see that, most of them were of higher stage. And the pre-operational kidney function was also of our great concern. As we can see, the DNA copy number gain regions was quite comparable and concordant with previous UC of bladder or UTUC cohorts. Lowever, in the copy number loss regions, we can see that there was quite diverse result. So that let us look into detail about the LOH, loss of heterozygosity. As we can see here, take this UTUC case as an example. On chromosome 10, there was no LOH, but on the chromosome 8, on the P arm, there was a copy number loss. And on the Q arm, there was a copy number gain without mosaicism. However, on the chromosome 18, we can see that on the tail of the Q arm, there was a copy number loss, but with a possible mosaicism inside. So this result was compatible with SNP array and NGS, as this case shown from Kaohsiung. So if we put the somatic mosaicism of Taipei, Kaohsiung, and Japan together, we can see that the percentage of somatic mosaicism was quite high, in UTUC. And as to the LOH, we can see that the LOH in Taipei and in Kaohsiung was significantly higher than that in Japan by either different kind of calculation method. Very interesting, the LOH event is associated with the preoperative estimated renal function. As we can see that with the poor renal function, the more LOH was noted. And the LOH event was also associated with gender. For the male gender, the LOH frequency was significantly high. However, the LOH event is not associated with stage or grade, which we thought to be very important risk factor for the cancer development. So make a brief summary. The percentage of LOH and somatic mosaicism in UTUC was quite high. And the pattern was different from Taiwan to Japan. Either in Taipei or in Kaohsiung, the percentage was significantly higher than in Japan. And the LOH event is associated with preoperational kidney function and with gender. However, it was not associated with stage or grade. So the sleep rate data told us that the genetic instability was quite high in UTUC. So we look into detail to compare some mutational signature. So from these three hospitals, we continue to do the next generation sequence and to look more into detail the mutational signature. It includes 39 cases from Taipei, 16 from Kaohsiung, and 16 from Japan. So for the somatic mutational signature, we look into the roles on environmental and genetic part. So according to the NGS result, we can see that in Japan, the mutational signature was quite similar. However, in Taipei and in Kaohsiung, there seem to be two different kind of group mutational signature. A little bit diverse, but the two group was a little bit obvious. And if we do the principal component analysis, PCA analysis, we can divide these patients into three groups. The first is the aristolochic acid associated group. And the second one is the DNA repair failure associated group. And the third one is others. So if we did the heat map analysis, still there are three groups can be divided. The AA group, the repair failure group, and others group. So if we use the one-way ANOVA test to make the statistical analysis among these three groups, we can see that in the AA group, the aristolochic acid associated signature S22 and the kidney failure associated signature S27 was significantly high in the AA group. But the age-related S1 signature was significantly lower in the AA group. And in the repair failure associated group, we can see that several double-strand DNA repair or DNA mismatch repair genetic related signature was higher in this group. However, the liver cancer associated signature, such as S12 and S16, was a little bit different in the repair failure group. And in the third part, others group, we can see that signature 11, alkylating agent-related signature was very significantly high in this others group. So if we do the tumor mutational burdens analysis, we can see that the TMB could be divided into three groups also according to this genetic grouping. In the AA group, the TMB was very high, but in the others group, the TMB was very low. In the repair failure group, we can see that the TMB was around 10. And if we look into the gene family, which gene family was frequently mutated in these three kinds of groups, we can see that in the AA group, most of genes were mutated in this AA group. But the KDN family was very a little bit higher in the repair failure group. So if we look into the specific gene in the test, we can see that the TP53 was very significantly mutated in the AA group. However, in the KMT2D group, in the repair failure group, there was no mutated in this KM2D. However, it was mutated more frequently in the others group. We know that in the others group, the mutational load was very low. However, in this kind of situation, there was no mutation in KM2D. However, it existed in the others group. So, if we compare the clinical features and the genetic data together, we can see that in the repair failure and other group, the stage was higher. And in the others group, the age of onset was younger than the other groups. And the gender distribution in the others group, we can see that it was female predominant. But we know that the male-female predominant phenomenon is not the same in Taiwan and in Japan. So if we did the analysis of Taiwan cohort only, we can see that the result was quite similar. But the gender female predominant phenomenon was even more obvious in the others group. And still, the others group with younger onset age. So we can make a little simple conclusion here that as to the TMD, in the AA group, the TMD was high, but in the others group, the TMD was low. And in the DNA repair failure associated group, the TMD was of median level. And in the others group, the age of onset was younger, and it is female predominant and with higher stage. So that makes us think about, is there any possible environmental risk factor that lead to the more young, early onset and female predominant phenomenon in this kind of others group with very low tumor mutational burden? And based on this result, maybe we can make a little bit suggestion for patients with UTUC. In the AA group, because the TMB was high, so the cancer immunotherapy might work. And in the AA group, there were much more genes mutated in this group. So the target therapy such as the FGFR3 inhibitor might work in this group. So this is also stated in the NCCN guideline. As to the repair failure group, the second group, because the TMB was of medium value, still the immunotherapy could work. However, maybe together with the targeting therapy such as the PARP inhibitor or some DNA repair deficiency inhibitor, the synergistic effect might work even better. However, in the others group, because the TMB was very low, so the traditional chemotherapy still have its role on this kind of patients. This maybe state a little bit for the NCCN guideline, because still the chemotherapy stands on the first line. And even in patients with poor performance status or with poor renal function, previously we think immunotherapy might work best in this kind of patient. However, there might be some inclusion criteria because not all the patients were suitable for cancer immunotherapy. So these are our results here to present it to you. Thank you very much and your comments.